We'll solve question number 5. In question number 5, it is given in figure 6.43 if PQ is perpendicular to PS. So where is PQ? PQ here is perpendicular to PS. Sorry. That means this is 90 degree, right? Next, PQ is parallel to SR. PQ is parallel to SR. So we can say PQ is parallel to SR. Fine. Angle SQR is 28 degree. So angle SQR is given as 28 degree. Angle QRT is 65. Angle QRT is 65 degree. This angle is 65. Then find the values of X and Y. Okay, here in X and Y, two angles are given. We have to find out the values. Now from the given information, so we will note down whatever information has been provided, and QPS is not written here as 90, but since they are perpendicular, we have written QPS is 90 degree. Fine. Now we can see that PQ is parallel to ST as it is given. Can we say that QR is actually a transversal? If QR is a transversal, then we can easily say that this angle here is equal to this angle. So these two full angles are equal. So that's why we will write it down. So since angle PQ is parallel to ST or SR, so SR is equals to ST only, right? So QR being the transversal, angle PQR, this angle PQR is equal to angle QRT, this angle. They are equal. Reason is they are alternate angles, right? Now, angle PQR is the sum of two angles, angle X plus 28 degree. So let's write down the value here. So X plus 28 degree is angle PQR. That is equal to how much? QRT. This is already given. Okay. So that's why it will be 65 degree. Now from here we can easily calculate the value of X. So X is calculated as 37 degree. Once we get the value of X, please box it. Now next we will have to find out the value of Y. So what we can see is in triangle PQS, in this triangle, we know the value of angle P is 90 degree. The value of angle X is 37 degree. So using the angle sum property of a triangle, we can find out the value of Y. So in triangle PQS, by angle sum property of triangle, these three angles, the sum of these three angles equals to 180. Let's put the values. We have put the corresponding values, and now we will calculate, and Y is coming out as to be 53 degree. So X equals to 37 and Y equals to 53 degree. That is the end of question number 5. Now we'll solve question number 6. In question number 6, this is a very complicated sum, and it is one of the most important sums of this particular exercise. Okay. So what does it say? It is an easy one as well as a complicated one. Okay. So let's go through. In figure 6.44, the side QR of triangle PQR. Let's focus on the diagram. Side QR of triangle PQR. So we have a triangle PQR and one of its base is QR. Its base is QR. Okay. And this QR is produced to a point S. So QR is produced or extended to the point S. Okay. That makes QS to be a straight line. Okay. Now, if the bisectors of angle PQR and PRS meet at point T. So where is angle PQR? So QT is the bisector of angle PQR. That makes these two angles equal. They are equal to each other because QT is bisector. What do you mean by bisector? A line which divides an angle into two equal halves is known as the bisector, right? So this angle PQR is bisected into two equal halves, okay, by the bisector QT. Another angle PRS is also bisected, okay, PRS this full angle is also bisected by the bisector RT. Okay, so this angle is equal to this angle. Clear? So these two are equal, these two are equal. We have marked it separately. Okay. Now they have said that these two bisectors QT and RT, they will meet at a point. Okay, and that point is T. Okay. So now what we have to do? We have to then prove that angle QTR, this is QTR, that will be equal to half of QPR. So here it is. So to solve this particular sum, we have to focus on these two angles. Okay, so we always have to focus on this and try to bring out relationships related to it. Okay, now in this diagram what we can see is for the triangle PQR, okay, we have a line extended as QS. So that means here a exterior angle is created, right? Angle PRS is an exterior angle of the triangle PQR. Yes or no? Again, for the triangle TQR, we also have another exterior angle, which is this one. Okay, TRS is the exterior angle of triangle TQR. We will use these two informations and try to relate them with the two angles. Okay, so let's write down whatever has been given. So it is given that angle PQT is equals to TQR. Why? Because QT is bisecting. That means these two angles will be equal, right? So that's what they have written here. Next, again, RT is the bisector. So PRT is equals to TRS. PRT is equals to TRS, as RT is the bisector. We will mark this two as equation 1 and 2. Next, in triangle QTR by exterior angle property of triangle. So what did we say? We have said that we will try to relate these two angles as because they are in the question. Okay, so how are we relating them? We are trying to do it by relating this angle to its exterior angle. Okay, we will relate these two together. So here we have angle PQR. So if we focus in this triangle, we can see that angle PQR, this angle plus this angle will be equal to this exterior angle. Sum of these two angles equals to the exterior angle PRS, right? And again, we can also say for the triangle TQR, this angle plus this angle is equal to the exterior angle here. We will forget about this particular triangle. Now focus here. This angle plus this angle is equals to, this is the exterior angle of the triangle TQR. Okay, we will utilize these two relations here. So for QTR, we are first writing this angle plus this angle is equals to this. So TQR plus QTR, TQR plus QTR is equals to TRS. Okay, now in the question we need QTR. So that's why we are rewriting this statement as this. So QTR is equal to TRS minus TQR. We have just taken this one to the other side. Now we have got a relation in terms of QTR, which is in the question. Okay, that's why we'll mark it as question number 3. Using the same property of exterior angle, in triangle PQR, we can write the sum of this angle plus this angle is equals to this whole exterior angle. So QPR, this angle, QPR, this, plus PQR, this is equals to this one. So we are writing here, sum of these two is equals to PRS, this complete angle PRS, okay, not this one. This complete angle is the exterior angle. Now, we have to relate these two terms, right? Now, here again, QPR is here, QPR is here. So we can write down QPR plus PQR is equals to PRS. Now we will try to relate it with this particular equation. but we do not have PQR or PRS here. So what to do? Let's break this angle. So we know that PQR, where is PQR? PQR. So it is bisected, right? It is bisected into two angles. Okay. One is this PQT, another is TQR. Now we know TQR is a part of triangle TQR. So which is right here, TQR in this equation. So we can relate with this one. Okay. So that's why we can break PQR into PQT plus TQR. Okay. And then PRS. PRS is also bisected by RT. So we can write PRS equals to this angle plus this angle. So we have written PRT plus TRS. Right. Now we will try to write everything with respect to triangle TQR, because we are trying to relate this angle with this one. From this equation we will come to this part. Okay. So we will take from these two parts, we will only take those parts which are related to TQR. Okay. So PQT is actually equals to TQR. These two are equal. So in that case we will write twice of TQR. Why? Because TQR is in TQR triangle. That is equal to, again, PRT plus TRS. Now TRS is the exterior angle, right? It is related to TQR. That's why we will choose TRS. Okay. So these two are also equal by equation 2. So that's why this plus this can be written as twice of TRS. Okay. Now we will take these two to same side. So we'll take here. So we'll get angle QRP is equal to twice TRS. This one goes to the other side, becomes negative and becomes twice angle TQR. Okay. So this one, from these two terms we can take common 2. Here we have 2 and 2. So let's take common 2 and write the remaining part in the bracket. Okay. Now TRS minus TQR, it's equation 3. TRS minus TQR is equals to QTR. So instead of this we can write here QTR, right? So twice of QTR. So here we can write angle QPR is equals to twice of QTR by equation 3 from here. So ultimately the question has asked angle QTR equals to something. So we'll bring it to the same format. So QTR will be equals to half of PQR. 2 goes to the other side, becomes half. So we have rewritten it and hence we have proved the equation.